Okay, so let's look at another example. It says use f of x is 1 over 3 minus x and g of x is 3 squared minus 16 to answer the following. Okay, so we want to find f of g, and then we're going to find the domain of that f of g. All right, so notice f of g of x, we don't have a number to plug in, so our answer should still have x in it. Okay, so we're looking for f of g of x. Remember, we always start in the middle, on the inside, and we just bring the f right down. So g of x is what? G of x is 3x squared minus 16. So we just figured out f of g of x. Now we have to find f of 3x squared minus 16. Well, what does that mean? We just take 3x squared minus 16 and plug it in for x in our f function. So instead of x, I'm using 3x squared minus 16. All right, and so that is our f of g of x. All right, next, we want to find the domain of that. So what's our one question when we're looking for domain? Are there any issues? And the two types of issues we've talked about is when we divide, we don't want a 0 in the denominator, and if we have a square root, we can't take the square root of a negative. So do we see any of these issues that could possibly happen? Well, we don't want to divide by 0. So that means the stuff in the denominator should not equal 0. So let's say this 3 minus 3x squared minus 16, this should not equal 0. All right, so let's see, what can x not be then? First, I'm going to distribute this negative. And combine like terms, so 3 plus 16 is 19. I'm going to subtract the 19 from both sides. Actually, I think life would be easier. Let me just add this 3x squared to both sides. So therefore I have positive numbers. And then divide by 3. Running low on space here. So x squared cannot equal 19 over 3. Take the square root of both sides. X cannot equal positive or negative square root of 19 over 3. So it can't be positive square root of 19 over 3, and it can't be negative square root of 19 over 3, because that will make this denominator 0. So let's put this in interval notation. Remember, if you struggle with that, you can always do a number line. I'll do it in green. And put our two x values on the number line. So our negative square root of 19 over 3 and our positive square root of 19 over 3. Okay, so what did we discover? X cannot equal those two numbers. So that means we're going to do open circles because we will not equal it. But can x be everything else? Yeah, so x can be all of this stuff that are not those. And so now it should be a little easier to write out our domain in interval notation. So from negative infinity to negative root 19 over 3. Union negative root 19 over 3 to root 19 over 3. Union root 19 over 3 to infinity. So basically we just rewrote our number line using interval notation. So this is the domain of our composition of functions. Okay, all right, let's look at B. Determine g of f of x. Same two functions, different ordering. So this time we're having g and we're going to put f on the inside of it. So remember, start on the inside. All right, so I'm going to be silent and let you work through this, and you can check your answer with me. All right, so did you get 3 times 1 over 3 minus x squared minus 16? That is the answer. All right, and then we want to find the domain of this g of f of x. So again, are there any issues here? Do we have any fractions or square roots? We do have a fraction. We just want to make sure the stuff in the bottom of the fraction does not equal 0. Perfect. X can't equal 3. So you can draw a number line if you want. I'm going to jump to interval notation. Here's our domain, everything except 3. Final question here, determine g of f of 3. Question, can you tell me the answer of this without doing any work? So g of f of 3, we already found g of f. G of f of 3 without doing any work, our answer is what? It should be undefined. How do we know this? Because we're plugging in 3, and that's not in the domain of our function. So we should not get an answer. But if you want to double check that that's true, we can plug 3 into here. Well, what does 1 over 0 equal? It's undefined.